Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Move pieces to obtain a string. Leetcode 2337. In this problem, we are given two strings start and target, both of length n. Each string consists only of the characters L, R and underscore. The characters L and R represent the pieces, where a piece L can move to the left only if there is a blank space directly to its left, and a piece R can move to the right only if there is a blank space directly to its right. The character underscore represents a blank space that can be occupied by any of the L or R pieces, and we should return true if it is possible to obtain the string target by moving the pieces of the string start any number of times, otherwise we will return false. Then in example 1, for the given string start, we can obtain target by making following moves. First, we can move this L piece to the left. Then our string start becomes L underscores R underscores R underscore. Then we move this R piece to the right. And now our start string becomes L underscores R underscores R. And finally, we can move this middle R to the rightmost point, and now our string becomes L underscores RR, which matches the target. So we will return true in this case. Similarly, in example 2, we will try to move R to the right because there is a blank space available and get underscore RL, but then we will see L, so R cannot move forward. So we are stuck with the string underscore RL, which doesn't match the target. So because of this, we will return false. Now to solve this problem, let's make some observations. First observation we can make is, since L's and R's can only move to the empty spaces and cannot swap or cross each other, the sequence containing all the L's and R's without underscores in start and target string must be same. For example, here we can see that the sequence of start is LRR and that matches with that of target, which is also LRR. Also, as a sequence containing L and R's is same, the characters L and R have the same frequency in start and target string. So first thing we can do is, when we start the algorithm, we can check if the string start and target are same without the underscores. And how can we do that? We can just replace all the underscores in both the strings with empty string and check if these two strings match, that is, they are equal. But would that be enough? And the answer is no. And here comes in the second observation. Since L's can move to the left and R's can move to the right, all the positions of L's in the start must not be less than corresponding ones in the target. For example, for the given start string, if we have the target string like underscore underscore L, then the string start cannot equal target no matter how many moves we make, because left can only go to the left, and here we can see that the first left in the target string is on the right of it. So this move is impossible. So because of that, we will return false in this case. Similarly, all the positions of R's in the start must not be greater than the corresponding ones in the target, because R can only go to the right. So for example, if our target string is R underscore and if our source string is underscore R, then again we cannot move R to the left. So the start string doesn't change. So because of this, it is impossible to obtain target string from the start string. So this was our second observation. And now the question is, how can we use this observation? As noted in the first observation, the sequence of characters L and R should be in the same order in both start and target string. So how about we use two-pointer technique to validate the movements? Let's use pointer I for string start and pointer J for string target. We can ignore or skip over the underscores in both the start and target strings. The goal is only to focus on the positions of L and R, because the underscore characters only provide the movement flexibility but do not affect the final sequence of L and R. And now, when we encounter a non-underscore character in both start and target, we see if the characters match. That is, ith character in start and jth character in target string are same. If not, that implies change of order, and hence we must return false in this case. And then we will check the movement constraint. Now, if matched character is L and it occurs at the ith position in start and jth position in target, then it should occur in such a way that j is less than or equal to I. This ensures that L can stay or move to the left but should not move to the right. Similarly, if the character is R, then ith character in start which appears as jth character in target such that j is greater than or equal to I. This ensures that R can move to the right or stay in the same position but should not move to the left. And we will continue doing this until all the non-underscore characters in both the strings are compared and validated. Now let's see this in action. We start with I on string start and j on string target. And first non-underscore character we see in both strings is L, which means the characters match where I is equal to 1 and j is equal to 0. So here we can see that j is less than equal to I. So this is a valid move and hence we will continue and find the next non-underscore character in string source and target. And this time we find R in both the strings, which is good because those characters should match. And we can see that index I is 4 and index j is 7. And here we can see that j is more than equal to I. So this is also a valid move. And so we continue with our iteration, finding the next non-underscore character, and we again find R, and that matches with next non-underscore character in string target, which is also R. And this time we can see that index I is 7 and j is 8. And again, j is greater than or equal to I. So this will also be a valid move. And now we are done with string s as well as t. So we will end the iteration. And we can see that all the non-underscore characters actually matched and they were also at the right position as per the movement constraint. So we will return true in this case. And now let's jump into the code part. First, let's check if the sequence of L and R within the start and target strings are same after removing the underscores. So we replace underscores with empty string in both source and target string and check whether resulting strings without underscores are different. If they are, then we will return false because it is impossible to transform one into another. Otherwise, we will start our two-pointer technique, for which we will define two variables I and j to traverse through string start and target, and n to check if the pointers are within the bounds of respective strings. Now we will start iterating on both source and target string using respective pointers. Now we will run the loop on the start string to find the next non-underscore character, and we will do the same thing for the target string as well. While doing so, we may actually reach the end of the string. For example, there may be a case where all the characters at the end of the either strings are underscores. And if one of the string has reached the end but other hasn't, then again it is impossible to transform. So we will return false, and we can actually use XOR operator to check that. XOR operator returns true when the inputs are different. So we can check if the conditions I less than n and j less than n XORing together returns true. If that is the case, that means only one of the condition is true. So we will return false in this case. Now if we are here, that means either we have reached end of both the strings or we have not reached end of any of the strings. So we check if we have reached the end of the string. We can just verify it by checking if, for example, j is at the end of target. If that is the case, then we are done. So we can break out of the loop and later return true. And now we check if the characters match. If they don't, then we will return false. Otherwise, if the match character is L and I is less than j, that is L in the start string is to the right of the final position in the target string, then it is impossible to make a move. So we will return false. Similarly, if the match character is R and I is greater than j, that is R in the start string is on the left of its final position in the target string, then again it is impossible to make a move. So we will return false. And finally, we move both I and j pointer forward in both the strings. And if we have reached the end of both the strings without encountering any issues, then the transformation is possible and we will return true in this case. Now let's submit this code. Cool. In terms of time complexity, it will be O of n, where n is the length of the string, start and target. Because in the worst case, we are going through all the characters of both start and target string. And in terms of space complexity, it will be O of 1, because we are not using any extra space other than some variables here and there. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.